3, what'd you do for 79?
He wants to take it.
A, why?
Because we
factor the bottom.
Yeah.
And what'd you get as the factors at the bottom?
And then you get 1/2 and 2, but 2 can't work, and you plug in 2 to the top, you get 0, and then that's 0, 0, and that would be more, that's a removable discontinuity, but if you plug in 1/2, you could get a number.
Nice. If you had put B, you were half right, but you didn't realize that x minus 2 canceled. That's a whole. That's a whole. What, Andrew? Because remember, you're looking for factors of 2 and factors of 2. And when you're doing the grouping thing like Crawford, you would have multiplied the outsides and you would have been like, what factors of 2 work? These ones do. So then you would have split this into a negative x and a negative 4x, and you would have grouped and you would have gotten that. Sarah.
Is there 2 times 1/2 1 0 to do like a whole or something?
We have negative 4, negative 1 is negative 5.
Oh, you just plug it into the whole thing, not the little factors piece?
Well, you
Pretty
solve.
sure I never will work, but.
No, it's okay. You solve, so you said vertical asymptotes can only be in the bottom. They can't factor out. You said equal to 0, so you add 1, divide by 2. It's just the 0 of the factor.
Okay.
And it's different than that one, because 1/2 plus 2 isn't 0.
Okay. I think
Does that answer the question?
I think so.
Okay. For number 80, let's go group number 8. That's applicable. Oh, we don't have a group 8 in this class. So sad. Group 7, though. We'll do the best we can.
A.
A? How come, Aaron?
Because when you graph it, it's just A.
That's one way. That's one way, when you graph it. What's going on? Who's secant?
1 over cosine.
1 over cosine, right? So theoretically, if I'm plugging in, not theoretically, actually, if I'm plugging in, I'd have 1 over cosine of negative pi over 2 plus 2 times negative 1. If we're just plugging in, right? What's cosine of pi over 2, though?
0.
0. So 1 over 0, what should this point us to? I know it's minus 2, but what is this? It's infinite, right? Number over 0. There's a vertical asymptote. If it's a vertical asymptote, automatically you have a 50% chance of getting it right. Right? It has to be one of the infinities. Then we have to figure out the sign. So if we're coming towards negative 1 from below, that's negative 1 from below. If we think unit circle, here's our negative pi over 2, right? What would be a number negative 1 from below? Negative 1.1, right? On the number line? So negative 1.1, negative pi over 2 and a little bit more. What quadrant are we in, guys? Third quadrant. What's cosine in the third quadrant? Negative. So I could say, hey, it's going to be a negative number. Sweet, that's negative infinity. They're all going to be negatives as you come from the left. That's like the cheater algebraic trick in the sense of unit circle. Negative 1 pi over 2, a little bit more negative coming from the left. That's quadrant 3, cosine's negative. If you were in quadrant 4, if it was from the right, it would be a positive infinity because cosine is positive. Anyway, number 81, group number 1. What'd you guys get? Which of the following is true?
Oh, sorry. I got D.
D? Let's check it out. You guys agree? The limit as you come towards 0 from above, which would be 0 from above 2, right? Is the same thing as you go towards 3 from above 2. Yep, I agree with that one. The rest of them wouldn't work so well. How many groups got all 3 right? Ooh, got at least 2 right. Nice. Got at least 1 right? I should have said got 1 right. That would make sense. All right, kiddos, we're going to go ahead and get into section 1.6 in just 1 second. Horizontal asymptote is basically. Let's go ahead and go to our, there we go, solutions manual. You guys keep me honest, just keep me going from even to even. Where are we starting? Color pens out, spiral, we're in the front, right? Just so we're all on the same page. Color pens out, we're in the spiral at the front. Homework number 5, solution 1.5. Angela, you said 2, yeah. Number 2, as you guys get ready to go. 2 from above would be positive infinity. 2 from below would be negative infinity. If you needed it, the overall limit would be infinity. What's our next even? 4. Oh, it's already up there. 2 from above is positive infinity. 2 from below is negative infinity. What's our next one? 6. He's over, but let me make it a little bit. They did it with words on this one, either way. As you come from the left or below, positive infinity. And as you come from above, negative infinity. Were you guys doing the little trick of plugging in 3.9 and 4.1? Nice. It makes it faster. You don't even need your calculator. What's number next one?
8.
Ooh, they agreed. You guys find one that agreed?
Yes.
The limit existed because as you come, 3.9 is going to be a positive with a negative. That's negative infinity. And even 4.1 is going to be a positive but with a negative. They're both approaching negative infinity. They agree. So the limit is negative infinity. Number next one.
12.
I know, I gave you guys a couple tabling ones, right? Just so that you have the experience of seeing as x comes in towards the vertical asymptote, the function decreasing without bound or the function increasing without bound, and that corresponds to what we see around -3 of, here's -3, right? Coming in from the left, it's negative. Coming in from the right, it's positive. So what would the overall limit be technically if we were to say it? DNE, because they don't agree. They're coming from the left, negative. Coming from the right, positive. Okay, number next one. 22, right? There he is. None. Why? It's a whole. How could you tell the short way without having to factor? What do you think the discontinuity is? 2. Plug it in, plug it in. 8 minus 8 is uh-oh. 2 minus 2 is uh-oh. That's not a vertical asymptote, right? That would be a whole. And if you did like polynomial division or if you did synthetic division, you would have gotten rid of it, but it didn't matter. Long story short, 2 is not a vertical asymptote. It's a whole. Remember next one.
28.
Ooh. This one might have caused some problems for some of you. Because yesterday we made a big deal. Every time you get number over 0, it's a vertical asymptote. Was this a number over 0? Okay, hold on. There's a forever quiz tomorrow, right? Question, what does ln of x normally look like? Swoop, right? Swoop, there it is. Okay, so anyway. What's going on at 0? At x equals 0? It's a vertical asymptote. Oh, we can have vertical asymptotes for things other than number over 0. Yeah, like ln. But hold on, wait. He was x plus 3. That means he shifts 3 to the, or another way of looking at it is, when is x plus 3 0? Because the 0 of the inside domain problem from pre-cal. Remember with ln, x has to be, or whatever's inside has to be no, not or equal to, greater than 0. So then if we take our x plus 3 greater than 0, x has to be greater than -3. So at -3, we have ourselves a vertical asymptote day. So it'd be this shifted to the left, so we would make our 0 here, 3, and a 2, and a 1, and a 0. That would be our graph. How many of you guys graphed them and looked at it? That's it? Oh, wow, that was fast. How many others of you were just confused? Ah. Okay, number next one.
44.
44? Here it is. This little baby one, negative infinity. Did you get the negative infinity?
No.
There was a minus in front. So if you plugged in 0 from above, this would have been a positive over a positive, but you're subtracting. You're subtracting. So you would have had 6 minus basically infinity. And this is going to actually help for today. 6 minus infinity. Why is that negative infinity? There's a 6 there. Who's stronger?
Infinity.
Now that's hard though, because our minds actually probably think the 6 is stronger. It's like, oh, it's established, yeah. But infinity means getting bigger and bigger and bigger. So 6 minus 10, 6 minus 100, 6 minus 1,000, 6 minus a million. Those are going to negative infinity. Does that make sense? Number next one.
60. No, 52.
52. 0. What? What? How is it 0? Okay. Word to the wise. Whenever we see negative exponents, our brains can't comprehend, so rewrite it. Limit as x goes to 0, positive. What does a negative exponent mean?
Over.
Over. So I can do e to the 0.5x, sine of x. First thing we try is plugging in, right? What's sine of 0? What's e to the 0? Oh, he wasn't even a problem. Because 0 over any number other than itself is? He was a tricky one. You might have thought that he was something funny, but he's not. What's our next one?
56.
56. What's the one after 56?
62.
Okay. Oh, he must be down here. Where's he? Where is he? There he is. 56. Do you guys find the error?
Yeah.
The final answer should have been negative infinity because you should have subtracted the 2. And so the limit of one of them is 1/2. The limit of the other is infinity. And 1/2 minus infinity, did we learn this from the other one? Who's stronger? Infinity. So it's going to be negative infinity. It's going to be negative infinity. 62. Nope. None. 4K. Can you ever make that 0? Can you ever make the bottom equal to 0? Set equal to 0, you get imaginary numbers. He has no problems. Number next one. That's it? Okay. This is on the tape for the lecture today, so if you guys need to have any more time with those evens, go ahead.
Cool graphics.
I realize you might have some questions on odds, so go ahead, ask me, ask others. There's the pink one, go look at CalcAB, look at CalcChat, and try to figure them out. Let me know. Come after school during lunch. We'll get a meeting today during lunch. Tomorrow. We're going on horizontal asymptotes in our notes. Horizontal asymptotes in our notes. Our goal today is to get through section 1.6 and maybe even start reviewing or at least talking about review. Some of you looked at the homework and were like, 1.6 is long. I know. But it's degree tests. It's degree tests. Which means it shouldn't take super long. Because you're not having to plug and chug necessarily. The first few are just some graphs. You guys can do this. And then, remember, if we get our testing on Friday, you basically have like a free weekend. It'll be nice. For me, I mean. Keep it. Yeah, go ahead. All right. You guys are setting up. I'm just kind of setting up the tables while you guys are writing. My mouse though, it's in the way. Silly. How could I approach infinity? How could I increase? I don't know. The way I increase. Limits at infinity. Sounds funny because it's like at infinity as though we're getting there, but it's not really that we're getting there, it's more that we're going towards. Remember, infinity is an idea, it's not a number, so we're not ever arriving, but we're headed that direction. You guys saw or can see how I approached infinity in the top table, how am I going to approach negative infinity? What do you think? Yeah, put a negative sign. Negative 10, negative 100, negative 1,000. Now, if you guys have ever found horizontal asymptotes, you're like, you don't need to do all this. Exactly. But I'm just saying, sometimes it can get a little tricky, especially if you throw in a sign or throw in an e to the x. The degree test might get a little bit trickier. So I'm showing you how you could think about it in a table. I'm showing you how you could think about it in a table. Let's do an example like the limit as x goes to positive infinity of 1,000 minus e to the x. Okay, I want you guys to use calculators. Go ahead, go in your table. You can make a hypothesis of what you think it might be. Then go ahead and go in your table, and I want you to actually, remember, table setup, have it and ask, delete all the old things you did before. Plug in 1,000 minus e to the x, plug in 10, 100, 1,000, 10,000. And ask yourself, what's it doing? I'm going to ask you guys for some numbers in just a second. If you don't have one, that's totally cool. Look on with someone in your group. Plugging in 1,000 minus e to the x. 1,000, that's a big number. Huh. I wonder if it's any stronger than 6 was in homework or 1/2 was in homework. What'd you guys get at 10? Anybody find that one yet?
Negative 21,026.
Ooh, negative 21,026. What's going on there? How about 100?
Negative 3 times 10 to the 43rd.
Times 10 to the what?
43rd.
Kiddos, can we just dot, dot, dot? It's negative and it's going a whole lot more negative. Because remember, times 10 to the, that means there's that many zeros after that. It didn't take long. Where is it going? Infinity, yeah, but which direction?
Negative.
Negative infinity. Now look at it. Could you have figured that out without using a table?
Yes.
Because you would have had 1,000, if we were to do fuzzy math, minus, what's e to the infinity? Infinity. Who wins, infinity or 1,000? Infinity. Right? Infinity wins. Because he can keep on expanding, 1,000 is stuck, and infinity can get past 1,000 pretty quickly. So therefore we could say negative infinity, just by kind of thinking about it algebraically. Okay? Let me give you another one going to negative infinity. What if I was to give you something like the limit as x approaches negative infinity of, let's go x. No, let's not do that. Let's do sine of x all over x squared plus 1. This is another one with a degree test. You might be like, I don't know what to do. How do you test the top and the bottom? But maybe, let's go in our table. The limit as x goes to negative infinity of sine of x over x squared plus 1. This might be one, once we learn the degree test or review the degree test, we're still like, ooh, we don't know how to do this one. Yeah. Okay, sorry, who's back? Sine of x over x squared plus 1. What'd you guys get at negative 10? 20.0054? Oh, 1. Point 0?
0.00539.
Okay, here are too many things. How about negative 100?
I got 5.1 times 10 to the negative 5.
Yeah.
What's it mean when you have times 10 to the negative?
there are.
It's that many decimal places before 5, right? Well, I guess go 1 and then go 4 more. Guys, what's it getting closer and closer to? It's 0.00.00000, right? It's going to 0. Now we're going to see in a second with our degree tests, a limit as you go to positive or negative infinity is only ever going to be 0 when the bottom wins. We'll talk about sine of x and x squared plus 1 and why x squared wins, and we'll always win over sine. But let's keep going. Can we use our table to try to figure these out if we're stuck? Yeah. But hold on. Let's do some easy ones first. But first, give high fives to everyone in your group because people are looking a little bit bedraggled this morning. All right, here we go. I know. I wish my voice could be a little more exciting. I want you guys to think through, what if you were to plug in infinity? What do you think the answers would be in these two?
Negative 1,000, I get a negative 8 times D. And then same thing. It becomes a negative. Not that for
Example. No. No, I couldn't. I had to go to search.
So for you know how sine fluctuates? Basically, it's fluctuating but getting closer and closer.
Okay.
Does that make sense?
How do you learn how to do
Are you guys thinking through? What if you were to plug in infinity?
The biggest infinity is negative.
Does 1 win against infinity?
No.
Does 2x, 2 times infinity, win against negative 3x to the 5th? No. So the question is, it's all one big strand and we're plugging in infinity. It's going to be an infinite answer, but you have to check the sign. What sign's going to win, just logically?
None of them.
Negative's going to win because that infinity is being raised. No, negative wins. But pause, why? Because you can think about it, fuzzy math, it's not really math because infinity is not really a number, but you have to ask yourselves, whenever you think about signs, who's the strongest? The little 2 times or the 3 times infinity to the 5th? The 3 times infinity to the 5th wins, hence it's a negative. How about number 2 though? What happens if you square root infinity? Now some of you are like, oh, stink, so it's like, I don't know, cut down? Yeah, but doesn't infinity keep getting bigger and bigger? So let's say take the square root of 25, it's 5. Take the square root of 100, it's 10. Take the square root of 144, it's 12. Take the square root of 1,000, it's 100. What's still happening as you expand what you're square rooting? It's still getting bigger and bigger, so it's going to positive infinity. So there are some things there's not really a degree test for. It's more kind of just visualizing and thinking about. And we can plug it in a table and we can check. But as you keep on getting bigger and bigger, with the numbers that you plugged in for x, the answers keep getting bigger.
But I see it.
You got cross country.
Just focus. Oh man, we're doing
Look
something.
far right. So you're gonna go flat.
Oh, we already learned this.
That's why you're supposed to like section 1. So
What's in the president?
Even though sometimes we don't have to think about the degree test. Whenever we have a fraction, we kind of do. Whenever we have a fraction, we have to think about the degree test. Now, there are technically more algebraic ways of doing this. That aren't quite as shortcutty, but we like shortcuts, right? So let's remember what we learned about horizontal asymptotes, and we're going to get to that in just a second. If the top wins, there is no horizontal asymptote because the limit will either be positive infinity or negative infinity. If the top wins, that means the bottom isn't going to be able to hold it down. So it's just going to keep on expanding to either positive or negative infinity. We're going to have to check the sign, which we've already kind of practiced a couple times today. We're going to have to check the sign. Number 2, what if they're equal? Do you guys remember what to do if the degrees of top and bottom are equal?
Leading coefficient.
The ratio of the leading coefficients. And the ratio of the leading coefficients is going to be a number. And if the limit as I approach infinity is a number, that means it is being restricted. And since it's being restricted, I am going to have a horizontal asymptote at, well, whatever that, I'll just call it L, whatever that number is, whatever that limit is. After you take the ratio, that is the horizontal asymptote. However, usually you can just take the ratio and you're good. But every now and then you actually still need to check the sign. I'm going to say, if you have square roots or if you have absolute values. That's when. If you don't have square roots or absolute values, you're probably fine. You don't need to check the sign. Just check the ratio of the leading coefficients and you're done. But when you have square roots or absolute values, why did I put a quotation? I don't really know. We'll put parentheses. Struggle. It's okay, I got it. If you have square roots or absolute values, you have to check the sign then as well. Now the nice thing is number 3 is the easiest one, hopefully, if you remember it. What happens if the bottom wins? He's going to hold him down and he's going to bring him to 0. So there's going to be a horizontal asymptote at 1 equals 0. And we don't need to check the sign because positive 0 or negative 0 is the same thing. It's still just 0. Now I'm going to go ahead and scroll down so you guys can see the horizontal asymptote. Just a quick reminder, basically, if the limit exists and is a constant, ooh, that's not going to help you much. If the limit exists and is a constant, there is a horizontal asymptote at the line y equals the answer of the limit. And technically, there only has to be a constant as you go one direction. Sometimes it's both directions. 2 positive and negative, they agree. But there's a big or. It is possible to have 2 different horizontal asymptotes as you go one way or the other. And I think in homework they may try to, and I may have tried to give you at least one example to show you that it's possible to have more than one. You could have 0 or 1 or 2. This isn't a forever card, not something to memorize per se, it's just more of something to understand. If the limit, as you approach infinity, is a constant, then there is a horizontal asymptote at that line. But have we done degree tests before? Yeah, so let's do an example. So we get a couple more seconds if you guys are still ready. Number 1, I'm gonna ask you a question. Everybody just shout it out. Who wins? Why?
Because it's power.
Remember, find the term with the highest degree. Top wins. I'm gonna circle that one. Technically, out of the bottom, that one wins, but overall, top wins. So therefore, my answer is going to be
No.
no horizontal asymptote. That's true.
Negative.
But what would my limit be? Why negative?
Because the -6 wins.
Because if I plug in an infinity -6 times, right, over, that's going to be negative infinity. How about the next one, number 2?
Oh wait, hold up. It's something important.
Who
Oh,
wins?
they're the same.
They're the same,
Hey.
right? Now, limits, we can take this big old cubed root outside. What's the ratio of leading coefficient inside? Right? Now I could simplify it. And I could go ahead and say negative, because it's a cubed root, the negative's okay, and the cubed root of 8 is 2. But either of these answers are correct, right? Either one is good. Is there a horizontal asymptote? Yes. And where is it?
There.
At y equals either of these, they're the same thing. So how about number 3?
Get it now.
Who wins?
The bottom.
The bottom wins. And whenever the bottom wins,
0.
which means there's going to be. So guys, the questions can look a couple different ways. They can look like find the limit as you approach infinity, or they can look like what is the horizontal, what are the horizontal asymptotes. I know we're almost done because it's chapel day.
Oh, we need to check.
I'm going to end on a tricky one that might appear.
Good.
Question, who wins?
Oh, hold on.
That's a tie.
Now, we're not allowed to actually break this apart, but we are allowed to say square root of a quadratic is a linear. Uh-oh, it's a tie. This is like that funny one in the summer packet.
Yeah.
What would be the answer?
3.
3 over, we square root the coefficient, that's our trick. But wait, pause,
Okay.
check the sign. There's a square root. If I plug in a negative, what's this?
Negative.
If I plug in a negative, square it and square root it. Positive. So my answer is negative 3. Negative 3. You can think of it like this. It's kind of cheating and it's fuzzy math, but that'll be a positive, that'll be a negative. I'm 45 seconds over. Thank you for your patience. Go rock 1-6 and steady forever cards 1 through 5. Bye guys. Go find me some limits at infinity.
We have this.
You have to find a way, and I'm like,
Look at that scratch on the side.
Scratch.
Which one's really hard to